Welcome to section 6. In this section, you're going to be learning about arrays in JavaScript. Arrays allow us to store lists of information. We might have a list of strings, a list of numbers, a list of objects, a list of whatever we like, and it's one of the last major data types that we still need to explore. So why are lists so important to software development? Well, think about any application that you use day to day, whether on your computer, your phone, or your even TV. When we open up our phones to respond to a text, what do we see? We see a list of all of the messages we've sent back and forth between that friend. If I go over to the weather app, we have a list of locations. If I click one of the locations, I have a list of temperatures for the week. When I turn on my TV, I get a list of all of the apps I have installed. If I go to the Netflix app, I have a list of all of the shows available to me. So being comfortable working with list-based information is essential to creating these real-world applications. I'm super excited to start talking about arrays, so let's go ahead and jump right into the next video where we start exploring the basic array syntax. Welcome to your very first video on arrays. In this one, you're going to learn the basic syntax for creating an array, a list of items, and we're going to figure out how we can interact with those array items, like reading their values, for example. Now, this section is going to work slightly differently than any of the sections we've had so far. In all of the previous sections, we've pretty much created a new file for every single video. We learned a new feature, and then in the next video, we created a new file and built up from scratch, learning a new feature. What we're going to focus on in this section, though, is creating just a few files and building up a more complex script. So once we bring arrays into the mix, we're going to have the fundamentals of the language down, which means that we'll be able to do more interesting things. So here's how this one's going to go. As we go through the videos, we're still going to learn new features. For that, we're going to focus on building a note-taking application. So in the first part of the video, as we explore a new topic, I'll be showing you in the context of a note-taking app. For the challenges, you're going to be focusing on creating a different application, a to-do application. And then at the very end, we'll have both of those apps, and the final section challenge will be creating a version of the expense manager that uses arrays. So we can actually track individual expenses and give them things like descriptions and amounts. Now, all of this is going to work a little differently than what we've seen in the past, but as always, we're going to work through everything in the video. There's no boilerplate code. We don't do anything outside of these videos. So if you watch and follow along with all of the challenges, you're going to be able to get through this one just fine. And you're going to be able to see how JavaScript can actually help us build applications. Over in the root of the folder, I'm going to make a new directory called arrays. And in here, we're going to add a couple of files. The first one is going to be called notes.js. This is where we'll build out a little note-taking script. And the second file that we're going to create is going to be called todo.js. And once again, for the moment, neither of these are going to be wired up to a user interface. It's just a script that runs. Later on, we'll wire up both of these to the browser so we can actually interact with it. All right, let's go ahead and also switch in the terminal to that folder, cd:/arrays. And now, as promised, we are going to work in the note-taking application file, and then at the end, your challenge will be over in the to-do file. Let's kick things off by creating our very first array. I'm going to define a constant notes for this one, and I'll set notes equal to my array. To create an array, we use these square brackets on your keyboard. That's these guys right here. And there we have it. We have an array. We have this list. It just has no items inside of it. If we want to add items, there are two ways we can do that. We can add items right here, right now, and we can also use various array methods, which we'll explore later in this section, to add items down below. Let's go ahead and initialize this array with some values, though. So we're going to type some stuff right in here. The individual items for your array can be anything. It could be a string, a number, a boolean, an object, a function, another array, but we'll stick with these simpler data types for the moment. So let's say for the notes, we have a list of strings where each string represents that note's text. To add the first string, all we do is we create a string right here in those curly brackets. If I wanted to add a number, I'd type the number. If I wanted to add a boolean, I'd type a boolean. In this case, though, we do want a string to be the first item, so I'll create a string and I'll type my note text. I'll call this one note1. Now we have an array with a single item in the list, but we can add as many as we want. We could have 0 if that's what made sense. We could have 1,000 if that's what our application required. Let's go ahead and add a couple more into the mix right here. To add another item, we add a comma after the previous item, then a space, then the other item. So it could be a number, a Boolean, or any other type. There is no need to have all of your array items be of the same type, although usually that makes sense. So right here, we will add another note, another string with the text note 2, and for good measure, we'll just add one last one, note 3. So there we have it. We have an array, a list with 3 items inside of it, and now we can start doing things with this notes variable. Let's go ahead and start by just dumping it to the console. That would be console.log notes. I'm going to save the file and run things from the terminal. Over here, node notes is going to result in us seeing our list. We have our list and we have our 3 items, note 1, note 2, and note 3. Now, there are a lot of interesting things we can do with arrays, and that's what we're going to spend most of this section covering. One of the most basic things is to figure out how many items are in your array. To do this, we use the length property, much like we do for a string. So if I want to figure out how many items I have, I can go ahead and use notes.length. Now, there are plenty of methods available to us. Length, though, is a property, so we don't actually call it as a function. We just access it like this, and we get the length back as a number. So in this case, I have 3 items. I would expect to see 3. Over here, that's exactly what we get. Before we go any further, as always, I want to make you aware of where you can find the documentation for all of this, so you can take your knowledge to the next level and use all sorts of different interesting methods. If you search for MDN array, we should get to the right place. Right here, we're looking for the array JavaScript page. And over here, we can see all of the various properties and methods we have available to us. Now, arrays are a method-heavy data type. So as you can see, we do have the length property. It's pretty much the only one we'll ever use. Down below, though, we have an extensive list of methods. That's because methods are so essential to working with arrays, and arrays are so essential to building meaningful programs. So there's a lot of different functionality built into this. For example, we can sort an array listing the items in alphabetical order. We could pull out the first 2 items and delete the rest. There are all sorts of things we can do, and we'll explore all of those in time. For the moment, though, let's go ahead and switch back over to the terminal and Visual Studio Code, and we're going to figure out how we can grab an individual item from the list. This is done via bracket notation. It's what allows us to grab an individual item from the list, and we grab it by its position. So let's say we want to grab the first item in the list and do something with that string. How do we get that done? Well, we start by referencing the array notes, and then we use bracket notation, which requires us to create some brackets. We open and close brackets right here after the array. Now, what goes inside of here is not more array items. It's actually a number. It's the position of the item we want to access. This is known as the index. The index is nothing more than the order the item comes in the array. Now, it's important to note that indexes start at 0 for arrays, and this isn't specific to JavaScript. You're going to see this with pretty much any programming language you use, which means that this would be the 0, this would be the 1, and this would be the 2. So everything is just off by 1. If I wanted to grab the first item right inside of these square brackets, I would type 0. Now let's go ahead and actually see if we get the string back by wrapping this in parentheses and tossing a console.log up front. I'm going to save the file and rerun things from the terminal. Right here, what do I get? I get note 1 printing. So now I have access to that string and I could do something meaningful with it. We can also grab any of the other items by their index. For example, if I want that last item, the 3rd item in the list, I would access it by its index, which is 2. I save things and rerun it, and I should get note 3. Now, if you access an item by its index and it doesn't exist, you're just going to get undefined back. As an example, let's say we try to grab an item with the index of 22, which clearly doesn't exist. If we rerun things, the script doesn't fail with some sort of error message. It just gives us back undefined, like we've seen in other situations. For example, an argument whose value was never provided. We can also access items starting at the end of the list. And to do this, we just perform a little calculation right here inside of these square brackets. We start off by grabbing the length. So notes.length. Now what's going to come back? 3 is going to come back. Does the index of 3 exist? No, because this is 0, this is 1, and this is 2. So 3 would account for the next item in the list. So if I wanted to grab the last item, all I do is subtract 1. Now we have a way to always get the last item from the list. And if we rerun things, we get note 3. And if I wanted to grab the second to last item, I could just do this. I could subtract 2 instead. If I rerun things, what do I get? I get note 2. So this is just the very basics of working with arrays. To wrap up this video, I'd like you to go ahead and use an array over here in the to-do file. What you're going to do is create an array of to-dos. So each one is just going to be a string describing what you need to do. That means you're going to create an array with 5 different to-dos. So go ahead and come up with 5 things you got to do, or 5 things just in general if your to-do list is pretty empty. Then you're going to print a little message that includes the length. So say something like you have X to-dos, where X is the actual length of the array. So you're going to want to use that length property. Then you're going to print the first and second to last items to the terminal. So you're going to go ahead and actually just print out the string for each of these. And if you want, you can give them a little bit of formatting. So you could say something like to-do, colon, space, followed by the actual to-do text, like walk the dog, for example. So take some time to knock all of this out. Go ahead and actually run your work once it's done and make sure you see the correct results over in the terminal. Take a quick moment to pause the video. When you're done, come back and click play and we'll move through things together. All right, how'd that go? Let's go ahead and kick things off by creating our to-do list. Const to-dos equals a new array using our square brackets, and I'm going to add a few items inside. Right here, I will add order cat food. Then I'll have another one, clean kitchen. I'll add a few more, buy food, do work, and then the last one could be something like exercise. Pretty good list right there. Now we have our 5 items. Let's go ahead and print our first message telling us how many to-dos we have. For that, you needed to use the length property. So I'm going to use console.log to create a template string. Some parts are static, one part is dynamic. You have something to-dos. The something, which goes right here between 2 spaces, is the length property. So $ curly braces to inject a value. What do we want to put in there? To-dos dot length. Excellent. Now that we have our first message printing, we want to print a little message for the first to-do and the second to last one. I'll add that right down below. We can do all of this right inside of a template string if we wanted to, or we could have created a variable and referenced that. The choice really is yours. I'm going to go ahead and do all of this in one line just so we can see what that would look like. Right here, I'll start it off with to-do, colon space, and the first one. So I'm going to inject. I'm going to access the to-dos array. I'm going to use bracket notation to grab one of the items by its index. In this case, I want the first one with an index of 0. Then I can go ahead and take this line, copy it to the clipboard, paste it down below, and just tweak it to grab the second to last item. For that, we want to take the length into account. So to-dos dot length -1 gets us the last item, -2 gets us the second to last item. So hopefully I see order cat food and do work right here. Let's go ahead and run the script and see what we get. I'll clear the terminal output and run node to-do.js. What do I get? I get you have 5 to-dos. I get the first one, order cat food, and the second to last one, do work. So there we have it. We know the basics of creating and reading from arrays. In the next video, we're going to continue working with our arrays, so stay tuned, and I'll see you then. In this video, you're going to learn how to manipulate your arrays. So we'll figure out how we can add new items, remove items, or replace existing ones. And we're really just going to be running through a series of methods on the array. The array has a ton of very useful methods, so we're going to be able to tackle quite a few in just a single video. Let's go ahead and kick things off by talking about how we can add a new item right on to the end of the array. So we got our list of notes. We could imagine that the user does something like submits a form with a new note. We get that string value and we want to add it on to the list. How do we do that? Well, we use the array push method. Let's go ahead and explore that. Before we do, I'm going to tweak this last line. Instead of printing the second to last item, I'm going to print the entire array so we can see how our method calls actually change things. Right here, we're going to make changes to notes. Now let's go ahead and use push first. That is notes dot. The method is push. Does it take an argument? Yes, it does. It needs to know what item you want to add on. So if I wanted to add a number on to the end of the list, I would type a number like 12. If I want to add a string on, which I do, we create a string and pass it in as the first and only argument. Now we can go ahead and provide the text for this note. Let's call it something like my new note. So there we have it. We have our very first method in place. Now we can run the script and see how this method changes the array. Node notes from the terminal. When I run it, what do I get? I see I now have a length of 4 up from 3, and I can see my new item right on the end. This is the item that didn't exist when I first initialized the array, but was added later via a method call. Now push adds something on to the end. We can also remove something from the end. This is done via push's companion called pop. Let's go ahead and explore that. And as always, there's going to be a list of all of the methods we discussed in this video in the PDF guide for the course. So make sure to check that out, and also make sure to open up the documentation so you can actually explore the list of methods over there in the sidebar. Now, this is notes.pop, and it allows us to remove the last item from an array. So does it take any arguments? No, it just takes an action. It removes that last item. And if we were to save things, we could see how this plays out. We would expect that it removes note 3 and then adds my new note. Over in the terminal, if I do rerun the notes script, that's exactly what I get. So pop removes an item from the end, push adds a new one. Now with pop, we actually do get the removed item back as the return value. So imagine we're creating a web app and someone deletes a note and we say a little message like, you just removed, and then we provide the note text. We could also have something like an undo button in case they clicked the wrong one. To use the removed value, all we have to do is store it in a variable or just add it to a console.log call. It's the return value from pop. So I'm just going to print it to the screen, console.log. Then at the very end of that line, I'm going to close that parenthesis. Excellent. So now we're removing and printing the last item and then adding a new one. If we run it, the final array is going to look exactly the same. The only difference is that we're now seeing the removed item up above. So the push and pop method focus on manipulating the array from the end. We have two other methods that focus on manipulating the array from the start. This is shift and unshift. Let's go ahead and explore how both of those work. So the shift method removes the very first item from your array. It works exactly the same as pop, where it returns the removed item. So I could add a console.log call. I could call notes.shift, passing in no arguments, and this is going to have the effect of removing note 1. If I run the script in its current state, we can see at the end we just have two notes. We have note 2 and my new note. Note 1 is now gone. Now, much like we have push to add an item on to the end, we also have unshift to add an item on into the beginning. That is notes dot unshift, and we pass in the thing we want to add. So I could say something like my first note, since it's going to get tacked right on the beginning. If I save the notes file and rerun things, what do we get? We get my first note showing right up at the beginning. So these are 4 common methods for manipulating your arrays. You have push and pop for the end of the array, and you have shift and unshift for the beginning of the array. Now, aside from manipulating an array from either the beginning or the end, there are other methods that allow us to do something from the middle of the array. The one I want to explore, which is a little complex, is called splice, and we can actually find it over in the list. Let's go ahead and pull it up real quick. So splice is going to allow us to add elements to the middle of an array or remove elements from anywhere in our list. It takes a couple of arguments, so let's go ahead and explore both of those. We're going to use it over inside of Visual Studio Code. Right here, let's use notes.splice. The first argument to splice is where you're trying to take the action. So are you trying to start at the second item, the first item? You need to provide the index. So to simplify this little example, for the moment, let's comment out all of the lines we have up above. I'm using command / or Windows / depending on your keyboard setup. So now we're just working with the basic array. We know exactly what's inside of it. So with splice, let's say we're trying to remove that middle item. So we provide the index, the starting point, in this case, 1. If I wanted to start at the beginning, I would use an index of 0. So we're going to start at 1, and the second argument we provide is the number of things we're interested in removing. So we can remove 0, we can remove 1, we could remove 2. For the moment, let's just remove a single item. So this has the effect of saying start at index of 1 and remove one item. So it goes to the index of 1 and it removes this item. If I passed in 2 as the second argument, it would remove this one and this one. I'm going to save the file and rerun things from the terminal so we can see what we get. Over here, what do we get? We get note 1 and then we get note 3. Now you might be asking, why would you ever provide 0 as the second argument? This basically does nothing. It says, hey, start at 1 and then delete nothing. Well, that's because the next argument, if you want to provide it, allows you to add an item at that point in time. So let's say I do want to add a new item as the second item in my array. All I do is I provide 0 right there. Then I can go ahead and provide the new item. This is the new second item. So the functionality of this method call isn't going to delete anything up above. All it's going to do is add this as the second item to the list. It's going to move note 2 to the third and note 3 to the fourth. Let's see this in action. I'm going to rerun things from the terminal. The output is getting a bit long, so let's use clear to clear things up, and then the up arrow key twice to rerun the previous command. I get note 1, this is the new second item, note 2, and note 3. So this allows us to put an item somewhere in the list. Now we know how to delete an item, and we know how to add a new item. You can actually combine both of them to replace an item. So I could say start at item 1, delete one item, then add this. This is going to have the effect of completely replacing note 2. We can run the script to prove it. Over here, we get note 1, we get this is the new second item, and we get note 3. Note 2 is no longer anywhere in sight. So we're going to be using these methods quite a bit to manipulate our arrays. We can actually also change the value of a given item using bracket notation. So let's go ahead and comment out this line as well. And down below, we're going to explore just one more thing. We know that we can read a value with bracket notation, meaning that I can access from the notes array the first item using my square brackets and the index of 0, 1 for the second and 2 for the third. Now, not only can I read a value, I could actually assign a new value. So I could set the item at the index of 2 equal to a new string. This is now the new note 3. This is going to have the effect of replacing whatever value was at that position. So it's very similar to what we did up above. If I save things and rerun things, what do we get? We get note 1 and note 2, and then where note 3 should be, we actually get our new value. This is now the new note 3. So splice is great when you're trying to remove items. It's also nice when you're trying to remove and add. But if you're just trying to swap out one item for another, you can use the basic old bracket notation to get that done. Now it's challenge time. Using what you learned here, I want you to make some changes to our to-dos array. I'm going to remove the comments from the previous challenge, and I'm going to tweak these console.log calls. We can remove the to where we print an individual to do from the list. We'll bring that functionality back in later. And all I'm going to do is dump the whole list so we can actually see how our method calls are changing things. Then we can remove some of those empty lines. And what you're going to do is add a few different calls right here. The first thing you're going to do is delete the third item. So using what you learned, I want you to delete the third item. For me, that would be buy food. The next thing you're going to do is add a new item onto the end. You can have this be whatever you want, whatever new to do you have in mind. And then the last thing you're going to do is remove the first item from the list. So all in all, I'm removing buy food and order cat food and adding something new on to the end. Go ahead and take as much time as you need to get this done, and you can refer back to the notes file should you forget how things work. If you want even more information, feel free to dive over to the MDN documentation and look up the details of any of the methods we've explored. Pause the video, and when you're done, come back and click play. All right, how'd that one go? I'm going to kick things off by deleting the third item. The best way to get this done is going to be to use the splice method. So right here, you wanted to use todos.splice. Todos.splice is going to take a few different arguments. First up, where are we starting from? I want to delete that third item by food. It has the index of 2, so I provide 2 right here. Now I provide the number of items I want to delete. In my case, I'm just trying to delete an individual item, so it would be 1. I'm not adding anything new in its place, so there's no need for that third argument. Now that's step 1. Step 2, add a new item on to the end. To do this, we could have used splice. We could have said start at the end, don't delete anything, and add this, but we can just use the push method instead. Todos.push, super simple. We can add a new item on right here, and I will say buy coffee. So now we have the third item removed, we have a new item on the end, and now we're going to remove the first item from the list. You could have used 2 different methods to get this done. You might have used shift, you might have used splice. Either way is going to work. We already explored splice, so we'll use shift instead. Todos.shift, we call it. It doesn't take any arguments, it just removes that item. Now I didn't ask you to do anything with the removed item, so there's no need to do anything with the return value from shift, which would be the string order cat food. We can go ahead and remove the comments, save the file, and run our script to see if we got things done correctly. Over in the terminal, that would be node todo.js. When I run the script, what do I get? I get clean kitchen, do work, exercise, and buy coffee. So buy coffee is sitting here on the end, and order cat food and buy food, the first and third items, they have been removed successfully. So there we have it. Using these methods, we can manipulate our arrays. We're going to continue talking about arrays in the very next video. We're going to figure out how to loop over our arrays and do something for every single item. I'm excited to get to that. So let's go ahead and jump right in. Now that we know how to manipulate arrays, I want to talk about something else we're going to often do with arrays, which is run some code for each item in the array. So imagine if I really do have a list of to-dos and I'm trying to print them to the screen. I would want to go through the entire list, get the text for each one, and use console.log to print it, or later on, use different JavaScript methods to render it in the browser. Either way, I want to go through the list of items, running some code for each. This is known as looping, and with arrays, we have a method that makes looping over our arrays pretty easy. We're going to mess around with this over in the notes.js file down below. The method that we'll be using to get this done is called for each, because we do something for each item in the array. We can access it via notes.forEach. It is a function, so we will call it as such. The for each method takes a single argument, and this argument is actually a function. So in the past, every time we've called a function, we've passed in argument values like strings, numbers, booleans, and objects, but we can pass anything in as a function argument, including arrays, which we'll see later, and in this case, other functions. So what we're going to do is call this method for each, and we're going to pass to it as its one and only argument a function. Now there are 2 ways to get that done. We could create a variable like const do this equals a new function. And then we can just reference the do this variable right here. That would successfully pass a function as the first argument, but there's no need to define a variable just to use it. So what we're going to see a lot in this course is us just directly defining the function right in line, which means right here, we're going to use the function keyword. We're going to open and close our parentheses, and we're going to open and close the curly braces. This function is where we define what to do for each item in the array. Now, this function itself is what's going to get executed one time for every item in the array. So if I have 2 items in my array, this function will get called twice. If I have 15 items in the array, this function will get called 15 times. And we can prove this with a quick console.log. Let's just console.log a couple of hyphens, or maybe the word testing 1, 2, 3. We can save the script and we can run it to see exactly what happens. Over in the terminal, I'm going to run it. That is node notes.js. And when I do, the first thing we see is testing 1, 2, 3, printing 3 times. Why 3 times? Because we have 3 items in our array. So we've never seen something like this before, passing a function into a function. When we do this, we're creating what's known as a callback function. So a callback function is nothing more than a function that gets passed to a function. Now in this particular case, you'll notice that we're never calling this function that I have highlighted directly. Instead, we pass it into the for each API, and in that code, that is where it ends up getting called. Now in this case, this function that we've defined gets called, and we've already proved that. We see the message printing 3 times, but it also gets called with some arguments that we can access in our code. We get 2 arguments. The first argument we get is the individual item. So we're running the function 3 times because we have 3 different items in the array. We can access the individual item here, which we'll see in just a second. Let's go ahead and do that instead. Right here, instead of printing testing 1, 2, 3, I'm just going to reference the item argument. Let's save the script and rerun things from the terminal. When I rerun them, what do I get? I get my 3 notes printing. I get note 1, note 2, and this is now the new note 3. So this is great. Not only can we do something, run a function, one time for each item in the array, we actually get access to that item so we can do something specific to it. Alongside of the item, we also get the index. So this is the position of the item in the list, and we could print that as well. Let's go ahead and print that first. So right here before this line, I'll console.log the index. Now we should see the index followed by the individual note. If we rerun the script, that's exactly what we get. The first note has an index of 0, and we get that note's text. Then we have 1, the note text, and 2, the note text. So using for each, we're going to be able to do something meaningful for each item in our array. And this is probably the most common array method that we'll end up using throughout the course. Now it's your turn to use for each on your own. Over inside of the to-do script, what you're going to do is replace this line right here with a for each method call. So on the previous line, we print how many to-dos you still have to complete, and that's fine. We're going to leave that in place. But what I want to do down below is print all of the items left to do. So instead of just dumping the array to the screen where we actually see the array data and the quotes from the string, we're going to have a nice printed list like we had here, but with real data. So what I want you to print is something along the lines of the following: 1 dot, and then it would be the first item, whatever that happens to be. Then it would be 2 dot followed by the second item. And obviously the first item and the second item are going to depend on what you put in your to-dos array. For me, after these changes, the first item would be clean kitchen, and the second item would be do work. So go ahead and actually use for each to print a little message like this. Make sure to get the numbering correct and make sure to also include the text of the to-do. When you run the script, you should see all of them nicely formatted in the terminal with the message up above showing you how many actually exist. All right, take some time to knock this one out using what we just learned. Pause the video, test your work, and when you're done, come back and click play. All right, how'd that one go? Hopefully you were able to get that done without too much trouble. We're going to be using for each here since we want to do something for each to do. That would be to-dos dot for each. Now we know that for each takes a single argument to function, so we're going to create that function. And we know when this function gets called, it gets called with 2 arguments. We get access to the individual item, so I could call that the to-do or the item, whatever I want, it doesn't matter. And then I get access to the index, and we're going to need both of these. We're going to use the index to set up the numbering, and we're going to use the to-do to print the to-do. Now, right inside of here, all we need to do is use console.log to print a template string. We could also calculate the position first if we wanted to. So I could say something like const num equals index plus 1. We start at 0, but we want to start at 1 while we are displaying it to the user. So we add 1 to it. And then we could console.log our template string. We are going to start off with the number. So right here, num. Then we're going to put a dot space. Then we're going to put the actual to do. So right here, to do. And there we have it. That's all we have to do. Now we could even move this right inside of the template string. I could add index plus 1 right here, but I'm going to go ahead and keep it as a separate variable, though honestly, either way gets the job done. Now that we have this set up, let's go ahead and remove the comments down below and actually test our work. I'm going to save the to-do script, use clear to clear the terminal output, and use node to-do.js to run it. When I run the script, what do I get? I get you have 4 to-dos, and I get my 4 to-dos. Number 1, clean kitchen. 2, do work. 3, exercise. And 4, buy coffee. So there we have it. Using for each, we were able to print a nice list of all the stuff left on our plate for today. Now that we have the challenge complete, that's where we're going to stop for this one. But I do want to take just a quick moment to recap. The only method we learned about in this video was for each. And the reason that I wanted to spend just a bit more time on this one, especially by itself, is because this is the first time we're ever passing a function into a function. When we pass a function to a function, this is called a callback function. The term callback function just allows us to better talk about our program. It's just how when we add a function as an object property, we call it a method. You could still call it a property and you wouldn't be wrong. The word method is just a bit more descriptive. Same thing with a callback function. We're still passing in an argument. It just happens to be a function. Now, in this case, we saw that our function got called one time for each item in the array, and it got called with some arguments. We got the individual item as well as the index. Now, for each is not the only array method that's going to use callbacks. As we'll see throughout the rest of the section, almost all of them will. We're going to continue messing around with arrays and building out our 2 projects in the next video. So let's go ahead and jump right in. In this video, you're going to learn about the for statement, which is an alternative looping mechanism. So it's an alternative to using for each. The for statement, also known as the for loop, is great because it doesn't require us to have array data. For each is a method available on arrays, so we have to have some sort of array in order to work with for each. With the for loop, we get a whole lot more flexibility. What I'd like to do is mess around with it down below. Then we'll create an alternative to the for each code above. Then you will use the for statement over in the to-do.js file. So let's go ahead and kick things off with an example. For this example, let's imagine you want to do something 3 times. Maybe you're trying to print the top 3 scores for players in your game, or maybe you're trying to count to a specific number. So let's say I want to print a message like this one, counting, ... followed by the current count 1, and then I would count up to something like 3. So counting 1, counting 2, counting 3. Now, obviously, if I only wanted to count to 3, I could add 3 console.log statements in. But now let's say I want to count to 1,000. You don't want to add 1,000 console.log statements in. And we also can't use a for each method call unless we had an array with 1,000 different items. So if we did want to do something like this, run a code a specific number of times, we don't have a way to get that done. With the for statement, we do. So let's go ahead and mess around with that. Let's start off with the reserved for keyword. Then we set up a set of parentheses. We'll talk about what goes in there in a moment. And then we set up our code block. So the code block is the thing that is going to run X number of times. And we determine how many times we want this to run by providing the configuration details right inside of the parentheses. There are 3 things we provide inside of here. The first is an initializer. The second is a condition. And the third is the final expression. So let's go ahead and talk about all 3 and actually set this up. we're going to have it count from 0 to 2. So 0, 1, 2. The initializer is where we set up the initial count. So if I'm trying to count from 0 to 2, I need to create a variable whose value is a number 0. If I wanted to count from 2 to 0, I would create a variable whose value is 2. So this is where we start things off and initialize that count. You can think of a 4 statements count kind of like the index. It represents via a number at which iteration in the loop we are. So let's go ahead and start at 0 by creating a new variable. Let count equal 0. Perfect. Now this is just the first of 3 things we have to provide. Right now we have a count starting at 0. The next thing we provide, the condition, determines how long the loop should run. We specify the condition right inside of the parentheses along with everything else, and to separate those 3 pieces, we use a semicolon, just like this. So we have our initializer followed by a semicolon, then right here we add our condition. The condition should be true if the loop should continue to run. The condition should be false if we should stop looping. In this case, we determined that we want to stop after the count is 2. So if the count is 0, 1, or 2, we want to run the code to actually print our little counting message. But if the count reaches 3, we want to stop because I don't want to loop on forever and create an infinite loop. So right here, the condition, if the count is less than or equal to, in this case, if it's less than or equal to 2. So that would pass for 0, it would pass for 1, it would pass for 2. When this reaches 3, this condition will result in false and the loop will actually stop. Now the third thing is just as important as the first 2. This is the final expression, and this is where we actually modify the count. So right now the count never increases. With the final expression in place, we'll be able to increase the count by 1 for every time the loop runs. So once again, after the condition, we add another semicolon, and we provide the third thing inside of parentheses, the final expression. Right here, we're going to set count equal to a new value that is count plus 1. Now we could use count minus 1 if I was counting down, and since we're just taking a number and incrementing it by 1, we can actually use the shorthand. So that could be replaced with count plus plus, which has the exact same effect. I could also use count minus minus if I wanted to decrement by 1 instead of increment by 1. In this case, we are indeed trying to increment, so we're going to use count plus plus. Now we're going to break down exactly how this runs, don't worry, but we do have to put something inside of here so we can actually see some sort of value printing when we run the script. All I'm going to do is console.log the count. So let's go ahead and just dump the count's value to the screen. I'm going to save notes.js. Over in the terminal, we're going to run that script node notes.js. And when we do, what do we get at the bottom? We get 0, 1, and 2. So here we are indeed seeing our for statement run 3 times. It runs once when the count is 0. It runs a second time when the count is 1. And it runs a third time when the count is 2. It never runs again for counts greater than 2, such as 3. So let's go ahead and actually break down what happens when this code runs. When our JavaScript code runs and we get to the for statement, what happens? We first run our initializer. This is what sets up the count variable, and the initializer only runs a single time, regardless of how many times the loop runs. In this case, the loop runs 3 times, printing 3 numbers, but the initializer only runs once. From there, we move on to the condition. We check the condition and see if the value is true. If it is, we're actually going to run the code for the very first time. So in this case, when we first start, the count is 0. We then check the condition, is 0 less than or equal to 2? It is, so our code executes printing 0 to the screen. After the code executes, the final expression runs, incrementing the count, then we move on to the next iteration. So once again, we check the count. The count is now 1. Is 1 less than or equal to 2? It is, so we run the code, printing 1, then we increase the count by 1. Now the count is 2. Is 2 less than or equal to 1? It is. So we go ahead and run the code with the count equal to 2. After the code runs and 2 prints, we increment the count to 3. Now we check the condition again. Is 3 less than or equal to 2? No, it is not. So the code doesn't run, the for statement completes, and we move on to whatever code would be down below. Now in this example, we are counting from 0 to 2, but we could always reverse that. I could count from 2 to 0 by starting the count off at 2 and reversing the condition. So I will check if the count is greater than or equal to 0. Then I could go ahead and decrement the count instead of incrementing it. So now we are going to count in reverse. If I go ahead and save the program and I rerun the file, what do I get? I get 210. So that's a quick rundown of how we can use the for statement. What I'd like to do now is talk about how we can use the for statement with arrays. So what we're going to do is use the for statement to recreate the functionality from for each up above. Let's go ahead and knock this out. We're going to create a new for statement down below. We set up our parentheses and our code block, and then we're going to configure things. Let count equal. Now, where are we going to start the count? Well, I'm going to start the count at 0. 0 being the index for the first item. After we initialize count, we can go ahead and set up our condition. Now, the condition in this case is going to take the array's length into effect. So we're going to keep running if the count is less than the array's length. So let's say we're trying to loop over the notes array from above. Right here, we would put notes dot length. Next up, we add our final expression. In this case, count plus plus is going to get the job done. Now, there are a couple important things I want to talk about related to this. First up, it's important to note that the count variable created is scoped locally to the for statement. So I can create one here, count, and a one above, count. If I try to access count down below, like console.log count, it would not be in scope. It is locally scoped to the for statement. The other thing I want to analyze is this condition right here. So let's imagine we have a notes array with a length of 1. So we only have one item we want to loop over, which means this code is only going to run a single time. We start with a count of 0. We then check our condition. Is the count less than the length? Is 0 less than 1? Yes, it is. So this code runs once for the very first time, count being 0. After the code runs, we increment the count value. Now the count is 1. Is 1 less than the note's length, which is 1? No. 1 is not less than 1, so we would stop and continue on running the rest of the program. So this is what we set up if I want to do something for each item in an array. Now we can go ahead and actually print the item. How are we going to do that? Well, we're going to access it using the bracket notation. So I'm going to grab from the notes array a specific item by index. Now we have access to the index. It is stored in the count variable. So right here, I am pulling out the individual item, and this is going to happen for each item in the array as the count increments. Let's go ahead and actually dump this to the console so we can see that. Console.log. I'm going to wrap our previous expression inside a parentheses. Then we can go ahead and save the program and run things from the terminal. I'm going to use clear to clear the terminal output, then the up arrow key twice with the enter key to rerun things. And these 3 lines, these are related to what we have from this last for statement. The first line, note 1, prints. The second one, note 2, and the third one, this is now the new note 3. Notice that these 3 values we're getting are identical to the 3 values we were getting up above when we used the for each method. So when we use the for statement with an array, the count becomes the new index. We then use the bracket notation to grab the item by its index from the array. Now, the cool thing about this is I could count in reverse. What if I wanted to print those items, printing the third one first, then the second, then the first? We could go ahead and get that done as well. Much like we did above, we want to start from the final position. So if I want to start from the last item in the array, the count needs to equal notes dot length minus 1. Now remember, if there's only one item in the array, the length is going to be 1. If we subtract 1, we get 0. That is the index for the first item. The next thing we do is reverse this condition and then change it. So I want to only continue running if the count is greater than or equal to 0. If it's greater than or equal to 0, then we're going to continue running. Otherwise, we'll stop running. Then we just use count minus minus. With those few small changes in place, we're now going to be able to count in reverse. I'm going to use clear again. I'm going to rerun the notes script, and what do I get? I get my third note, then my second note, then my first note. So when we use for each, we have to have an array and we have to count from beginning to end. When we use a for statement, we have a bit more flexibility, making it a great tool to have in our tool belts. Now I want to give you a bit of experience using the for statement. What you're going to do is use it over inside of the todo.js file. What I'd like you to do is print the exact same stuff we're printing above with for each. The output would be something like the following. Right here, we still want to print the items in order. So we have number 1, order cat food, number 2, clean kitchen, and we would continue on until the end of the array. In this case, I happen to have 5, so the last one should be 5 dot space exercise. All right, take some time to knock this out using the for statement, then test your work by running the todo.js file. Take a moment to pause the video, and when you're done, click play. All right, how'd you do? Let's go ahead and kick things off by using the for statement right here, for. Then we're going to set up our parentheses and we're going to set up the code block. Now in this case, we want to count from beginning to end. So I am going to start off with a count whose value is 0. Let count equal 0. The next thing we provide after a semicolon is the condition. In this case, I want to keep running as long as the following is true. Count less than, in this case, to-dos is the array, so to-dos dot length. The last thing we provide inside of parentheses after another semicolon is our final expression. We're counting up from 0 to the array's length, so in this case, that would be count plus plus. Now, inside of here, we have access to that count value, and we can get the exact same information that we had been printing above. We're still going to set up a console.log call, and I'm going to leave this as a template string. Just like we did above, we're going to calculate the number. So const, not in uppercase though, const num equals, in this case, it would be count plus 1, since we have the count variable and not the index variable. Then we could also create a variable for the individual item, for the to-do. This was not necessary. Maybe you used bracket notation inside of the template string directly. Either way works. Right here, though, I am going to grab it. So we're accessing something from the to-dos array. We're going to grab it by index, and the index is stored in the count variable as a number. Now we have both of those pieces of information, just like we did up above, and we can set it up the exact same way. So first up in the template string, I have num, then I have a dot space, then at the end, I have the actual to-do. Perfect. That's all we had to do to knock this challenge out. Let's go ahead and test things out by heading over to the terminal and running clear to clear the terminal output. Then I'm going to run node todo.js. When I run it, what do I get? I get the exact same thing printing twice. I have it printing first for the 4 items using the for each method. Then down below, I have it printing again using the for statement. Now, when I set up the challenge, I said I had 5 items. I forgot I actually deleted one in the code right here. That's why we're seeing 4 as opposed to 5. So there we have it. That is the for statement in a nutshell. Now, obviously, we don't need to loop over these arrays twice, so we're going to go ahead and remove the duplicate code. If I have an array and I am counting in order, I like to stick to the for each method. If I don't have an array or I'm trying to count in a different order, I'll use the for statement. In this case, we're counting in order and we have an array, so we can stick with for each, which we had before. So I'll delete the for statement. Then we can clean this file up as well. Right here, we can remove the for statements we had set up since we are working with the notes array and we are counting from beginning to the end. If you want to learn more about the for statement, you can always find it on the MDN documentation by Googling MDN for. If I run that Google search, it's the first one right here. Here it talks about all of the things that we just talked about. It talks about those 3 things down below. We have the initializer, the condition, and the expression, and we have the code that we actually run. That's the code that we had inside of the curly braces. Like with all of the pages, it comes with various examples that should all look familiar by now. All right, that's where we're going to stop for this one. I'll see you in the next video where we're going to continue to talk about and work with arrays. In this video, we're going to take a look at how we can see if something exists in an array. Now, there are a few different ways we can get this done, and in this video, we're going to make the transition from an array of strings in both cases to an array of objects, because a note isn't just a string. A note probably contains other pieces of information we want to model as well, like a title, a body, maybe when the note was created, who created it, all sorts of different information. And the same with a to-do. A to-do is not just a string. It might be assigned to a specific date or a specific user in your application. It might be completed or uncompleted. So these are all things we want to associate with each item, not just some string data. Before we switch things up though, I do want to explore a couple of features down below. Let's say that we are creating this application and we have our list of notes, and now we decide that we want to find if a note exists or maybe locate it so we can do something with it, like delete it. The way we get that done is using the index of method, and it's super easy to work with. You just access it on your array, notes dot. We type it out, index, uppercase O of, and then we pass in the thing that we're looking for. So in this case, let's say we're looking for an item in this array whose value is a string. So we'll open some quotes, and it contains note 2, for example. This is going to return a number. It's going to return this item's position in the array. If there are multiple strings with note 2, it'll return the position of the first one. So if it was the first item, we would get 0 back. If it was the second item, we would get 1 back. And if it doesn't exist at all, we get -1 back. So let's see this in action. Console.log. Around both sides of our index of call, I'm going to run that script, which is node notes.js. And when I do, we're looking at the very last log. This is the number 1 showing us that it is indeed right there as the second item in the array. Now let's switch that up. Let's say, for example, I change it to a lowercase n, in which case it's not going to find a match. In this case, over inside of the terminal, I would get, as promised, -1. So when we see -1 from index of, we know that the item you searched for was not anywhere in the array. If we get any value greater than -1, including 0, then we know the item is indeed somewhere in the array, and we could go ahead and do something like remove it or modify it to fit our needs. And now let's go ahead and see how switching things over to an array of objects is going to affect this behavior. So up above, like I mentioned earlier, we're not going to have strings as the individual array items. Instead, we're going to have objects. So how would we do that? Well, we just define a new object right here in those square brackets. I could define 1 object, 2 objects, and 3 objects for the 3 notes. Now, the formatting that we typically use for this is to hit enter inside of each set of curly braces, and that brings us to something that looks like this. While this syntax might look a little weird at first, working with arrays of objects is so common in JavaScript that you'll get used to it in no time. And in here, inside of each object, we can define the properties that make up that object. In this case, the properties that make up each note. And we're going to have 2. We're going to have the title, and the title is what we had before. It's all we had before. So a title for the first note might be something like note 1, or in this case, I could say my next trip. Let's say I'm planning out a vacation. Now, aside from just the title, we're also going to add other properties onto the note. And the other one that we're going to add for now is the body of the note. So what is the actual text value of the note? And I could just say something like, I would like to go to Spain, something I'll likely be doing this summer. Now, this is just one of the notes. We're going to go ahead and crank out 2 others as well. So title. Right here, I could say habits to work on, and then maybe I'll list out some things I'm trying to improve. I could just say exercise, and I could add another one right here, eating a bit better. Perfect. And we'll crank out just one final note. So down below, title, and this one will be office modifications, and I'll just say something in the body like get a new seat. So go ahead and crank out 3 notes for yourself. And what we're going to do is explore how changing things to an array of objects affects the behavior of what we've explored so far. First thing to note is that all of the methods are still available. It's still an array. So we can pop off the items, we can push new items on, we can shift and unshift. Although in this case, we would likely push an object as opposed to a string, since that's the structure we're now working with. We can still modify our array items, and we can still use for each to print everything out. What I want to do for the moment though is comment out all of these lines, leaving just a couple of console.logs in place to clean up the output. Now what we're going to do is figure out exactly how index of is going to work with an array of objects. So let's say I have an empty object. I'm going to add one right on here. Empty object, comma, space. Then down below, I search for the empty object. So right here, I remove the string and I try to see where in my array I have an empty object by providing one right there. I then save the file. I'll clear the terminal output to clean things up and rerun the script. When I rerun it, what do I get? I get -1 printing. Right above though, I do see my array. I have my empty object, I have my next trip, habits to work on, and office modifications all showing up correctly. So what exactly is going on here? To explore this behavior, let's go ahead and refresh our memories by opening a file we created in the last section. The file was objects references. And when we went through this video, the whole point was to show you that when we pass an object to a function, what we get access to isn't a clone of that object with the same properties. It's a reference to the exact same object in memory, which means that if I were to change account.expenses, we would be changing the original object that was passed in as the first argument. In this case, down below, that was my account, and we did indeed see my account change. We mentioned that this object is stored in memory, and what my account stores is a reference to this object's location, and the same is true with account. That is why a change to 1 is reflected in the other. So let's go ahead and bring this back to what we just explored over in notes.js. The index of method works by going through your array from beginning to end and checking if the item it's currently looking at equals the item passed into index of using triple equals. If it finds a match, it returns that index. If it gets all the way to the end and it doesn't find a match, it returns -1. We already saw that. So if it uses triple equals, we know that something like 1 equals 1, but what about an empty object equaling another empty object? Well, we can go ahead and figure out exactly what happens by saving the file and rerunning things, but the very fact that I'm actually saving it and rerunning it should likely believe you to know that the expected answer is not the one we're going to get. And that's true. What we get is false, not true. So when we're comparing two objects, it does not matter if they have the same set of object properties and the same object property values. That does not make two objects equal. What makes two objects equal is if they're the exact same object in memory. So let's see what that might look like. Let some object equal an empty object. Then we let other object equal some object. So like we explored previously, we have an object stored in memory. Some object is a reference to it, and then later on we make other object a reference to it as well. Now let's go ahead and switch up our equality operator. I am going to check if some object triple equals other object. Now we can go ahead and save notes.js, and over here inside of the terminal, we can go ahead and rerun the script. This time around, we get true showing up. So objects are only equal to other objects if they are actually the exact same object. It does not matter if two separate objects have the same properties with the same property values. Now we just proved that that's going to break index of for our purpose. And I mentioned that arrays of objects are super popular. So why would this super popular structure, an array of objects, not be able to use basic methods like index of? Well, the truth is we can't use index of, but in the array methods list, there are a whole bunch of methods specifically designed for use cases like this. So let's go ahead and explore an alternative way we can get the index of something in our array, knowing that that something is an object. Let's start by deleting these 3 lines, though I will leave the other console.log calls in place. And over on the MDN documentation, we're not looking for index of, which we already explored right here, that always uses triple equals when comparing the item passed in with the item in the array. What we're looking for instead is something that gives us a bit more flexibility. That's going to be find index. In the end of the day, we're going to get the same thing back, the index or -1 if it didn't exist, but find index is going to allow us to work with our array of objects. Now, as we can see in the example, yes, it works with all sorts of arrays of any type. Let's go ahead and see how it does that job. I'm going to switch back into the terminal and then over to Visual Studio Code. And right here, we're going to kick things off with a call to notes.findIndex. Now the call signature for findIndex is going to look very similar to what we explored with for each. What do we pass in to findIndex? We pass in a function. This function gets called one time for each item in the array, and this function right here gets called with the individual item. Since we have an array of notes, I might call this item a note, and we get access to the index of the note that we're currently working with. Now in here, we can just console.log the note to prove that this is going to go through all the items. I'm going to save things in its current state, and over in the terminal, I'm going to rerun the program. But this isn't particularly interesting seeing our objects print, since for each does the exact same thing. This isn't the goal of findIndex. The goal of findIndex is to actually find the index, and unlike for each, it has a meaningful return value. So right here, const index equals, and then we could console.log the index. Console.log index being either -1 for no match or the actual index if there was a match. Let's go ahead and clear the output in its current state and rerun things to see what we get. Right here, we get -1. Now we're getting -1 not because the thing we're looking for hasn't been found, but because we haven't really set up findIndex to work as it's supposed to. With findIndex, what we do is we return either true or false. If this item isn't the thing we're looking for, we return false. If it is the thing we're looking for, we return true. So let's imagine I'm trying to find the note where the title is Habits to Work On because I want to read it or delete it or something along those lines. What I do is I look at note.title, and then I see if it equals something else. So in this case, the string habits to work on, which is indeed an exact match with what we have above. Let's go ahead and see what happens when we save the file in its current state and rerun things. For clarity, I will clear the terminal output and rerun the script. And what do we get? We get we get our array, we get our objects printing, and then down below, we get what we really came here for, which is indeed the index. We've got 2 showing up, meaning it was the third item in the list, and it was indeed the third item. Right here, we have our little empty guy, which scooched it from the second position down to the third position. Now you'll notice something interesting about the output. Now it doesn't have to do with the first 2 console.logs. It has to do with what starts when findIndex runs. That is all of this stuff down to the very end. We get our empty object, which is expected. It wasn't a match, so it continues on. We look at my next trip. It wasn't a match, so it continues on. We look at habits to work on. It was a match. We then get our index, and you'll notice that we never actually run this function for office modification. findIndex looks for the first match it finds. When it finds that, it stops running the function, which makes this efficient. If I have an array of 1,000 items and the second item in the list is the one I'm looking for, we don't have to spend the computational power to go through the other 997. Getting through this video took a bit more time than I thought it would, so we're going to go ahead and consider this part 1 of 2. In the next one, we'll continue looking at arrays of objects and finding items in an array, and it'll also include some challenges for you to actually go through with the to-do application. For now, though, let's take a quick moment to recap. In this one, we learned about index of, which uses the triple equality operator to go through our array and find an item. We saw that work with an array of strings because a string like S is indeed equal to another string S. This is true with strings, numbers, and booleans, but it is not true with objects as we saw. So we weren't able to use index of to find the item in the array of notes. Instead, we used findIndex. Instead of using triple equality on the entire object, we can specify our own search criteria. In this case, the search criteria was, does this title match this string? In this case, we are able to use the triple equalities because one string does equal another. Let's go ahead and remove this empty object up above, and I will see you in the next video, which is part 2 of this one. Let's jump right into it. Welcome back to part 2 on finding things in an array. In the last one, we learned about index of and findIndex. We learned that index of always uses triple equals, which means that it's not a great fit for arrays of objects, which we want to be able to model real world things. So we switched over to find index, which allows us to specify our own way to compare two things. In this case, we're looking at the titles. In this video, we're going to break this out into a more real-world example by creating a function that works with our notes, and we're going to explore another method, and we'll wrap things up with a challenge where you're going to need to add a few functions for the to-do application, as well as convert the array to an array of objects, adding in more properties. Let's go ahead and start with the beginning now. So what I want to do is remove all of the code right here since we no longer need it. If you want to remember it, don't worry, it's still available in the previous lecture zips, and I also talk about it in the PDF guide for the course. Right here, what we're going to do is create a new function, const find note, and I am going to set this equal to, and what we're going to do is define a new function, and it's going to take in two arguments. It's going to take the notes you're searching through, and it's going to take the note title that you're looking for. So note title, for example. Now we're going to set up find note to return the actual note object if we find one, and we'll return undefined otherwise. So we're not going to return the index, not particularly useful in the end of the day. What we want to do is return the actual note object so we can do something meaningful with it. In this case, dump it to the terminal. Later in the course, show it in the web browser. So down below, if we were to call find note, it would work a little bit like this. We would maybe store the return value, the note that we found, and we would call find note, passing in something like the notes we're searching for. Currently we have that in the notes array, and the text we're looking for. So we could say find a note where the title is office modification, where capitalization is indeed important, but once again, that's something we could adjust for later. Then down below, we would console.log the note just like this. And there we go. We would be able to see the note if it was found, or we would see undefined otherwise. Let's go ahead and actually get this in action. Down below, I'm going to comment out all of the other lines we have so far, and we're going to focus on just this stuff, just on our array of notes and the find note function. So what's the goal here? The goal is to find the note. So we'll start by using find index to get its index. We'll then be able to use the bracket notation we already explored to actually get back the object. So I can go ahead and search for it right here. Const index. I can set it equal to. Here we're going to use notes dot find index, just like we did below. We pass in our function. The function gets called with those two arguments. We get called with the note and the index. Now you don't have to name index if you're not actually using it, so you could leave it like this. I'm just providing it here to remind you that you do have access to both of these. Later in the course, when we get more comfortable with the methods, we can just define the ones that we're actually using. So what's the goal inside of here? The goal is exactly what we did down below. It is to return true or false, depending on whether or not that note title equals what was passed in. In this case, what was passed in below was a static string, so nothing was really passed in, making this code not particularly reusable. Up above, though, we're defining a function that can be called as many times as we like. So what we're going to do is take that second argument, which is a string, and use that in our comparison equality operator. So right here, triple equals note title. Let's take a quick moment to break down what we have so far. So we call find note, we pass in the array to search and the search text we're looking for. So we can forget everything else. We can focus on just this function, knowing we have an array and some text. Inside of this function, we use find index on the array in an attempt to find the note whose title matches note title. How do we do that? Well, in the function for find index, that's what we specify. We check if note title equals the note title that was passed in. If it does, we're going to return true, meaning that is the match. If it doesn't, we're going to return false. Now we go through the entire array. If at any point in that search process we find a match, we store the index in the index variable. If we get to the end and we don't find a match, we store -1. That means at this point we have access to that number up above. It's either -1 for no match, or it is the actual index. Now we can focus on what we actually return from find note, because remember, this return statement is related to this function, not to the find note function. What are we trying to return? The note. So we're going to access that notes array. We're going to use bracket notation to get the note by index. For example, in the past, we typed in a number. In this case, we're still using a number, but it's not a number we type right in line. It's a number that comes from a variable. So I reference the index variable up above. If index is 0, we'll get the first one back, obviously going all the way up to whatever the array length is. If it's -1, we'll get undefined back, and that is exactly what we're hoping for if we don't have a match. Let's go ahead and save notes and see what happens. I'm going to save the file and rerun things from the terminal, node notes.js, and when I do, I get my note showing up. I get office modification. It was indeed a match. Now this is great because we can really customize how we search for things, but we could even take things a step further. Right now, what we have using triple equals is a case-sensitive search. So I have uppercase O and uppercase O. If I were to search for office with a lowercase o, I would no longer have a match. Over here, what do I get? I get undefined coming back. Well, we can actually go ahead and modify what qualifies as a match. To do that, we have two strings. How do we fix this problem? We just convert them both to either all uppercase or all lowercase, taking the case out of the equation altogether. I'm going to go ahead and use to lowercase. So to lowercase right here on this string, that's title, and the same thing over here, to lowercase. So we convert both of them to lowercase, then we check if those are equal. That's going to create a case-insensitive search, where this would be considered a match since we convert all of the characters to lowercase before comparing them. If we rerun the program, we now have our program working as we wanted to. We have our case-insensitive search, and once again, we're getting office modification showing up. So being able to customize what qualifies as a match goes a long way towards creating a real-world application that's not going to frustrate and piss off your users. Just one more method I want to explore, and then it's challenge time. So in this case, we're using findIndex to find the index, and then we're directly grabbing that item out of the array. There's actually a function that does some of this for us, making our life a bit easier. In the documentation, the one we're looking for is just called find. Find pretty much functions exactly as we set up the findNote method. We specify our search criteria by passing in a function, and when we find it, we get that item back as opposed to getting its index back. Let's go ahead and see how this would change things in our program. Now I am going to leave this function completely intact. What I'm going to do is take it, copy it, duplicate it down below, and then comment that version out, and up above we'll work on a modified version. I can also remove the comments down below, no longer any need for those. And now up above, we're going to modify our function. Now, most things are going to stay exactly the same. And the reason is that the call signature for findIndex and find are identical. So we can literally just swap out the method name. We still get this function called, we still get the note, the individual item, and the index, which means that down below, all of our code still references things that actually exist. Now find, once again, it goes through your array from beginning to end. Once your function returns true, it stops, just like findIndex. Although it doesn't return the index of the match, it returns the match itself, which means that what we get here is not index, it would be more appropriately called note. We could then return note down below to wrap up our alternative version. Now it's important to note that while find does return the object, it will return undefined if no match is found, much like findIndex returned -1 if no match was found. So if you're looking for the item directly, find is a great choice. If you're looking for the index to do something like remove it by its index, then findIndex is a great choice. Both of them are super similar. The only difference is what you get back from the method. Now we can simplify this further. We create a variable, and then the only thing we ever do with it is return it. We could just add the return right here. So I remove the const, the variable name, and the equal sign, and I directly return whatever comes back from our find method call. Now I can remove this last line, and there is our modified version. Now, both of those would be considered fine ways to get the job done in terms of code quality and performance. I'm just showing you two different ways we can work with our arrays when it comes to finding things. Now let's prove that it actually still works by rerunning the script. I'll rerun it. I do get office modification showing up. And if I were to change this to something that doesn't match, like some other office modification, I would expect to still get undefined back. And if I run the script, that is exactly what we get. All right, last comment before the challenge. It's that arrays are also passed by reference, which means that if I pass an array into a function and I make a change to that array, I'm going to see it reflected in the original one, just like we saw with our objects. I pass an object in, I change the object, the original object is also changed. That means if in find note, I did something like notes.push and added on a new note, it wouldn't just change the local array, it would also change the one that was passed in, which is this guy up above. So it's important to keep that in mind. Notes.push isn't modifying some sort of clone, it's actually modifying that original array. Now, the reason I tell you that is because you're going to have to use just that to complete the challenge. So over in todo.js, it's going to be up to you to write a little bit of code and make some changes to some existing stuff. I'm actually going to kick things off by deleting all of the code we have so far and outlining what I'd like it to do inside of comments. The first of two things I want you to do is the easy one. This is to just convert the array of strings up above to an array of objects. The array of strings limits our ability to model a to-do accurately. We're going to switch to an array of objects so we can add on more properties to make our to-dos more real world, like knowing whether or not they were completed. So right here, convert array to array of objects. And each of our to-dos, each object in that array is going to have two properties. The text is just the string we have above, so we already have that information. And the other one is going to be a completed property, which is going to be true if the to-do is completed and false otherwise. Now, when you convert your items, make some completed and some not completed just to switch things up. That's step one. Step two is going to be to create a function that works with the array of objects, and the one that you're going to create is going to allow us to remove a to-do. Right here, create function to remove a to-do by text value. So I want to be able to provide some text like buy food to remove that item from the array completely. Now it is going to be an array of objects, so we're going to need to use some of the methods we just talked about. Down below, I'm going to give you two things. I'm going to give you the function call, so we're all on the same page, and a quick console.log. So the function is going to work a bit like this. You could call it something like delete to do. It's going to take the array that you're looking for, the thing to remove should live inside of there, and it's going to take the text for the thing to remove. So I could say I'm trying to remove the to-do with a text value of buy food. Now notice that the cases do not match up, so I want you to make this search case insensitive just like we did before. Now the delete to do function doesn't need to return anything. If it finds a match, it's going to delete it. If it doesn't find a match, it's going to delete nothing, and then what we're going to do down below is use console.log to print the to-dos array to see exactly what changed. So in this case, I would expect one of the items to be deleted. If I had it on some extra characters, I would expect the to-dos array to remain unchanged since delete to do wouldn't find a match. Now, when it comes to the contents of that function itself, you're going to have to use the techniques we just learned about. How do we delete a to-do? Well, we talked about how to delete an item from an array based off of its index, which means that you need to find the index of the item. If it is found, if it's 0 or greater, you want to use the other method we explored to actually delete the item. If it's not found, you don't have to do much of anything. Now, I'm not telling you what the specific methods are because I want you to start remembering this stuff, or at least refer back to previous code and videos. If you have to refer back to those, that's perfectly fine. In the real world, people use resources every single day to actually develop at their job. When I'm creating courses or working on client projects, you better believe I'm on Stack Overflow and MDN, either remembering how something works because I haven't used it in a while, or learning something for the very first time. So take some time to knock this one out. In the end of the day, make sure it does work. Make sure the delete to do function deletes something if it exists and doesn't change the array if it doesn't exist. Pause the video, knock this one out, test your work. When you're done, come back and click play. All right, how'd that go? Let's kick things off by converting our array. I'm going to do that right here. Const to-dos equals an array of objects. Each object has 2 properties, text and completed. I'm going to move a little fast through this array creation process since you should already have it in place and it's pretty boring. So what I'm going to do is take this template of a to-do and copy it 4 more times. So right here, comma, space, paste it, and then I'll comma, space, paste for a total of 5 elements. Now in this case, we're getting some strange formatting. We'll talk about how to properly format documents in a little bit using Visual Studio Code. For now, I'm just going to highlight all of these lines and use Shift-Tab to de-indent them. Now we can actually fill things out. So the first one is order cat food. I have done that, so I'll leave that at true. Then down below, I have clean kitchen. I did not do that one, so I can go ahead and convert that completed value to false. Next up on the list, we have buy food. I went to the grocery store yesterday, so I'll leave that at true. Next after that, we have do work. I'm doing work right now, so clearly I'm not done. We'll switch that to false. And the last one is to exercise, which I have done. Excellent. So you should have created an array something like this, and once you have the array of objects, we can delete the array of strings. No need for that anymore. The next thing you needed to do was create that delete to do function. Now these challenges, as you can see, are going to start getting harder and harder, requiring you to put the pieces of the puzzle together. I'm going to be less explicit with how to solve a problem, and I'm going to be more general, telling you exactly what it should do, but not how it should do it. So let's go ahead and look at one way we could have gotten this done. We'll start by creating our function const delete to do, and we'll set it up as a function with the correct arguments. The first one being the to-dos to look through, and the second one being the text of the to-do to delete. You could have called that something like to-do text, and then we'll open and close those curly braces. Looks like I have one extra space right here. Not going to crash the program, but we do want to stick with consistent formatting. Now, we know how to delete something from an array. We use splice, and we know that splice requires the index of the item. So the first thing we're going to do is use find index to find the item in the array if it exists at all. Const index. We're going to call todos.findIndex, and we're going to call it with the function it expects. Now, remember, this function does take the arguments. We take in the individual to do in this case and the index. Since I know I'm not going to use the index, I'll just leave that off. And in here, all we have to do is set up the return statement. We return, and this is where we specify the criteria for saying that, yes, this to do matches this to do text. And for us, it's going to be accessing the todo.text property. For a case-insensitive search, I'm going to convert it to lowercase using that method. Then we're going to check if that equals, and right here, we're going to look at the to-do text that was passed in, and we're going to convert that to lowercase as well. Now we're in a situation where we have the index. It's either -1 for no match, or it's 0 and above for a match. So I'm going to check if index is greater than -1. If it is greater than -1, we know we have a match. What are we going to do? We're going to remove an item. If it is -1, we don't even need to do anything. There's no need for an else clause. In here, let's go ahead and use todos.splice to remove the item. The first thing is the index where we're trying to start. We already have that value right there. The second one is the number of items to remove. We're just trying to remove 1, so we'll provide the static 1 right in line. And there we have it. This is all we need to do to create the delete to do function. Hopefully you were able to get at least part of that done, and maybe you even solved this whole thing. Let's go ahead and see if we solved the whole thing by running the script. Over here, I'm going to run the program. That is not the notes file, but the other file. So let me back out. todo.js. And when I run the file, what do I get? I get 4 items: order cat food, clean kitchen, do work, and exercise showing up. The removed item, buy food, is nowhere to be found. That means we did get an index back. The index was greater than -1, and we successfully removed it. Now remember, splice only works because arrays are also passed by reference. That means when we modify this array right here, it's going to change the one that was passed in, which is this guy up above. Down below, we can make sure it doesn't do anything if it doesn't find a match. Let's add some extra characters in. I'm just going to toss a couple exclamation marks up front, just some gibberish to make the two different, and I'll rerun the script. When I do, this time around, I can see that all 5 items are showing up. So nothing was removed because there was no match, and that is exactly what we were hoping for. All right, that is it for this video. We have our delete to do function in place. I have plenty more to say about arrays because they are so critical to structuring our application data. So we're going to continue talking about them in the next video by figuring out how we can filter our arrays. For example, what if we just want to get a list of the to-dos that have yet to be completed? Let's go ahead and jump right in. In the last couple of videos, we've figured out how to find an individual item in our list. This allowed us to pull back a specific item based off of the title in our Notes app, and it allowed us to find a specific item and delete it in the To-Dos application. Now, in these cases, we're targeting one item in our array. But what if we wanted to do something a bit different? For example, what if I didn't know the exact title for my note, something that's probably the case, but I know that I put trip in it, or I know that I put office somewhere in the text. Currently, we don't have a solution for that. We're going to focus on adding that in this video, and the same thing is going to happen in the to-do application. What if we want to get a list of just the to-dos that haven't been completed so we know what we actually need to work on? Now, this concept is called filtering. We take an existing array and we create a new array with some of the items based off of whatever the filter is. So if I were to filter by items that haven't been completed, I would get a new array of objects back with just this item and this item. If I was creating an email application, I could filter by a specific author. I would go from a list of all my emails to a list of emails just by that person. Now that we have a general idea of what we're working towards, let's go ahead and actually implement this. And we're going to start over in notes.js. What we're going to do is create a companion to find note. Instead of finding a specific note by the exact title, we're going to create one that's way more flexible. It's going to allow us to provide a search term, and if that text exists anywhere inside of the note's title or body, it'll be considered a match. So let's take a look at an example. If I was using this application and in the search box I typed something like trip, I would get a list of notes back. It would contain just one, the only one that has trip mentioned somewhere in the title or the body. Now, if I were to search something else like NE, it would search all my notes and it would match any note where I have NE back to back. I have that in the first note with the partial word right here, part of the word next in the title, and I have it down below in the last note. It's part of the body. So both of these would be considered matches, and I would get both of them back to do something with them. So providing this flexible searching and getting multiple items back is going to be super important for really working with arrays in a meaningful way. Right here, we are going to first explore this technique outside of a function, and then we will wrap it in a function so it can be used and reused. Let's go ahead and kick things off by messing around with it. The method we're going to be using is called filter, and you can find it over in the array documentation. If we scroll down to F, we got filter sitting right here just above find, and like many of the methods we've been using with arrays, it takes a function as its one and only argument. Now down below, you're seeing something that looks like nothing we've ever worked with before. Don't worry, we will address exactly what this is, and by the end of the course, this syntax will make sense. For now though, let's just go ahead and switch back into the terminal and Visual Studio Code and actually implement this. So it is notes, our array, dot filter. Filter gets called like our other array methods with a single argument, which is a function. And like our other array methods, we get this callback called with two things: the individual item, which I'll refer to as a note, and the index, which I'll just call index. Now in here, what we do is we return a Boolean, which is going to be pretty similar to what we saw with find index and find. If we return the Boolean true, then that means this item should be kept in the new array we're generating. If we return the Boolean false, that means this item should not be part of the new array we're generating. So if I were to search NE, for example, I would want to return true for this item since it would be considered a match. I'd return false for this item since it doesn't contain the characters NE back to back, and down below I would return true for this one as well. Now, filter gives you back this new array. It does not make any changes to notes. So I could create a variable to store the return result. Const filtered notes, for example, and I'll set this equal to whatever comes back from filter. And then before we actually do anything, all I'm going to do is console.log filtered notes. Now, to keep things simple at first, what we can do inside of filter is just return true. This is going to generate a new array, filtered notes, and what is it going to do? It's going to have all of the same items as notes because we consider every single one a match. Whoops, I accidentally dragged that text. I don't even know why that's a feature anymore in these editors. Let's go ahead and run the program to see what happens. That is node notes.js. What do we get? We get our array right here, and we have every single item, all 3 notes. If I were to return false, we would have no notes be considered a match, which means that filtered notes wouldn't be undefined. It would actually just be an empty array since there are no matches. Right here, if I run it, that is exactly what we get. So filter is always going to return an array. It's just whether or not there are any items in that array. Now that we've seen how this works, let's go ahead and actually swap out the static Boolean with some code that actually makes the calculation to see if a note should be considered a match. The logic in here is going to be similar to things we've done so far. There's just going to be a bit more of it because we're comparing the title and the body. So what I'm going to do is actually not put all of this on one line. It would be a super long line spreading way past the edge of the screen. Instead, I am going to break this up into a couple of different lines, and that's great because we'll look at alternative ways to structure our code, all of which are perfectly fine. It's okay that there's multiple ways to do something. In most cases, both of those ways are perfectly valid. What we're going to do right here is start by figuring out if the title is a match. We're going to ignore the body altogether. So const, I'm going to call this one is title match. And here we're going to work on generating a Boolean, true if the title is a match and false otherwise. Once again, we do not care about the body at all. That'll come on the next line. Right here, what's the goal? The goal is to look at the note title. So that would be note.title. We're going to make this search case insensitive. So we'll take this string and convert it to lowercase by calling the method. Now what comes back from this? It's a string. I want to talk about something which is called method chaining. From here, we know that is title match is a string. So let's go ahead and switch that up and just call it something like title. Down below, if I wanted to wrap up this feature, I could use title.includes to figure out if the title includes some other string. And this is perfectly fine, but we can actually just chain includes right onto the end over here. So let me use the undo command to back up, changing the variable name back to isTitleMatch. And what I'm going to do is add .includes. Remember, what comes back from note is an object. What comes back from note.title is a string, which means we can call the string method. What comes back from the string method is another string, which means we can call another string method, the includes method, which we already explored. Now what I'm going to do is pass into includes the search text. In this case, the search text will come from a function argument, but for the moment, we can just type in some characters. I'll stick with NE, for example. Now, we are going to take these and convert them to lowercase, but we'll focus on that when we actually create the functionized version. So we have isTitleMatch all set up, and now we can move on to isBodyMatch, which will be very similar. A new const isBodyMatch equals note.body.to lowercase. We get a string back. We're going to use includes, and we're going to check if that string includes the search string, which is just the static NE. Now down below, we're going to use some of our logical operators to return the correct thing. We want to return true if isTitleMatch is true, or using the logical OR operator, isBodyMatch is true. So as long as one of those is true, I want to return true from this callback function. And that should be match with an uppercase M. So this is going to make sure that we are searching everything, and the result is going to be that filtered notes will contain a subset of all of our notes. Let's go ahead and test our work by saving the notes file and rerunning things from the terminal. When I do, what do I get? I just get notes that have NE. In this case, we're seeing the first one and the last one. If I were to switch up this string to something else, like office here and office down below, I would expect just that last one to be a match. Right here, that is exactly what we get. We get an array back, and we get back just a single object in that array. So these would be the search results we would show to the screen, something we will do later. For now, we're just dumping them to the terminal. Now that we have this in place, let's wrap it in a function, and then we'll be all done moving on to the challenge. I'm going to call this one const find notes plural. Whoops, that's find, not fine. So this is going to return multiple notes, hence the pluralized version. It will be a function, and it will still take in 2 arguments. The first argument we're going to take in is still the notes to search, and the second argument we're going to take in is your search text. I can just call this one query, for example, although you could call it anything you like. Now what we're going to do is take all of this code we just wrote, minus the console.log, cut it out, and just paste it right inside of the function. All we need to do to make sure this actually works is use query. So instead of putting the static string here, we're going to use whatever search text the user provided when they called the function. Right here in includes, we pass in query, and we'll convert it to lowercase to make the search case insensitive. And down below, we're going to do the exact same thing. Query dot to lowercase, calling it as a method. So in the end of the day, what does this highlighted code do? It resolves to a string. So in the end of the day, we're passing a string to includes, which is perfectly fine. Now all we have to do is actually return something from find notes. Down below, I could return filtered notes, and that would get the job done. But once again, there is no need to define a variable and then just return it. We could remove the variable declaration and just return whatever value we were originally assigning to it. So I'll remove const, the name, and the equal sign, and just put return right there, making this return redundant. Excellent. Now that we have a find notes function in place, let's go ahead and actually test it out and make sure it still works. Right here, in console.log's argument list, I'm going to call find notes. That makes sure I print the return value. I'm going to call it as a function because it is one. I'm going to pass in the notes to search and my search term. For this one, let's go ahead and target that middle note. I will use the word work for that. I'm going to save the file. Over in the terminal, we can rerun the script, and what do we get? We just get a single note back. We get habits to work on. If I were to target the note by the body instead of something in the title, I can use eating, for example. I would expect to still match that second note. If I rerun the script, that's exactly what we get. In both situations, we're getting the habits note back. Now we can search as often as we want and with whatever value we need. Now that we've explored filter, it's time for you to use it on your own over inside of the to-do application. What you're going to be doing is creating a function that shows just the to-dos that have yet to be completed. Down below, I will give you a sample function call, although it's going to be your job to actually create the function. I'll comment out our call to delete to-do, and what we're going to do is call console.log so we can dump the output to the screen. We're going to call this new function, which doesn't yet exist, but we could call it something like get things to do. We'll call it as a function, and this one just takes a single argument. It takes the list of to-dos to search. Now, later on, we might have a more complex to-do application where we have 6 different lists, one for work, one for home, one for a hobby, and we might want to call get things to do for each list. So that is why we take the list in as a function argument. In this case, we just have one list, but we want to make sure that our functions allow us to be flexible in the future. So we're taking the list in as that argument. Now it's your job to actually create the function that uses filter to get a list of just the to-dos that have a completed value of false. So that would match clean kitchen and do work in my case. I shouldn't see the ones that have already been finished. For me, that would be order cat food, buy food, and exercise. Those should not be showing up, just clean kitchen and do work. Take as much time as you need to knock this one out. Define the function, set up your filter call, and return that new array. Take a moment to pause the video, test your work, mess around with some of the values, and make sure the output changes if you change their completed values. And when you're done, come back and click play. All right, how'd that one go? Let's go ahead and kick things off by defining the function I'm using already. Const get things to do. This is going to be a function, so I'll set it up as such, and we are going to take an argument, so I can add that into the mix. I'll call this to-dos. Now, inside of the function, the goal is to return something. We're trying to return a new array. Now, I already kind of know where this function is going to go, so I'm just going to start it off with a return keyword, and then I'm going to use to-dos.filter. So what am I returning from this function? I'm returning the subset of all the to-dos, that new array. I pass my function into filter, and I set up those function arguments. I get access to the individual to-do, and I get access to the index. Now, once again, you don't have to name the index if you're not using it, so I could leave this off. I'm just adding it to remind you that it does indeed exist. Inside of filter, our goal is to now return true for the ones we actually want to keep. Those are the ones where the completed value is false. So how do we get this done? Well, I can return. I will look at to-do.completed, and I will check if it equals false. If to-do.completed equals false, the result of this comparison operator will be true, meaning that true is going to end up returning. Let's go ahead and save the file and run things to see if it actually works. Over in the terminal, I'm going to clear the terminal output, and then I'm going to go ahead and run that script, node todo.js. When I run it, what do I get? I just get clean kitchen and do work. Now, we could structure this a different way as well. What if we removed the highlighted code here and just referenced the Boolean? Currently, it's the opposite of what we want. We're going to end up returning false for the to-dos where we actually want to return true. So we can just flip the Boolean value using the logical not operator, which we explored a few sections ago. This is going to make sure that for to-dos that have a completed value of false, we return true, meaning they stay in the list. And for to-dos with a completed value of true, we return false, making sure they're filtered out. Both ways of solving the problem are perfectly fine, and if we run the code, we're going to see they both actually get the job done. Now let's go ahead and just tweak things a little bit to make sure our changes are reflected. I'm going to say that I have not ordered cat food and that I did clean the kitchen, which is indeed true. I can save the file, rerun things. We can see clean kitchen is gone and order cat food is now inside of my things to do. Using the filter method, we're going to be able to take an array and get a subset of that array back, and this is super powerful for searching. There are just a few more things that we're going to talk about related to arrays before we continue on to the next section and figure out how all of this fits into the browser. In the very next one, we're going to look at how we can sort our arrays, putting, for example, completed items last or sorting our notes in alphabetical order. I'm excited to get to that, so let's go ahead and jump right in. Welcome back. In this video, we're going to talk about sorting our arrays. And there's actually just two videos left for this section, this one and the next one. This one's sorting. The next one is going to be a project video where you create a newer version of our expense manager using what we've learned about arrays and arrays of objects. Then we'll move on to the next section where we actually connect all of this to the browser. Now, when it comes to sorting our arrays, depending on what data we're storing, we want to sort by different things. So for a list of notes, we most likely want to sort by the title as opposed to by the body. For a list of to-dos, we probably want to sort by the completed status, putting ones that haven't been completed at the top of the list and ones that have been completed down at the bottom. So with each application, the sorting order is really going to depend on the specific data you're working with. Now, regardless of how you're trying to sort things, the method you use is the same. This is the sort array method. So let's take a look at how this works. To kick things off, I want to pull up the MDN documentation for the sort method, as it's a bit more complex than any of the other array methods we've worked with so far. If we scroll down to the method that's sort, we can check it out. Now, the sort method doesn't require a function as the first argument, though it can take one. For arrays of simple data types, the sort method is just going to try to sort things alphabetically. So right here, for example, we have an array of strings. When we call the sort method, the months array is now a bit different. Instead of going from March, January, February, and December, we have it in alphabetical order with D first, then F, J, and M. So with strings, sort can intuitively figure out that we probably want to sort things alphabetically as opposed to something else like the length of the individual string. But there are plenty of other situations, like with array of objects, where this is not going to actually do much of anything. It's similar to what we saw with index of. Index of worked great with our simpler data types, but when we tried to use index of with objects, it failed. If we tried to use the sort method with an array of objects, it's not going to let us specify the specific criteria we want to sort by. But sort does take a function which allows us to specify the exact comparison behavior. If we scroll down a little bit, we can see that sort takes an optional compare function. This compare function allows us, the developer, to define the sort order. So for the notes, I want to sort alphabetically by the title. For the to-dos, I want to sort the completed items at the bottom of the list, and the ones that haven't been completed, I want those to appear up at the top. Now, there is a bunch of information about how the compare function works, since it can be a little tricky. We're going to go ahead and set it up exploring exactly all of this stuff, but a bit more organically, as opposed to just reading this wall of text. Over in the terminal, I'm going to switch over to Visual Studio Code, and we're going to kick things off by creating a new function for our notes. Const sort notes equals a new function. We're going to take in the notes to sort, and that's it. We don't need anything else. Inside of this function, it's now time to figure out how to use notes.sort. As I mentioned, calling notes.sort isn't going to do anything for our array of objects. What we need to do is provide it a function. This function, also known as the compare function, allows us to determine if one thing should come after or before another thing. Now, unlike our other array methods, which had the function called one time for each item, the function for sort actually gets called with two individual items. So in this case, it gets called with two notes. When we're creating the sort function, or you look at any examples of someone using it, they typically call the first one A and the second one B. Both of these are going to be some object from the array we're sorting. So A could be this one, and B could be this one, for example. It's our job to look at A and B and figure out which one should come first. Depending on which one should come first, we return one of three values. If A should come first, we return -1. If A should come after B, so B should come first, we return 1. If both of them don't have their order changed, they're identical in order, for example, the two to-dos are already completed, then we could return 0, saying that the order doesn't need to be changed up. So we're going to end up returning one of those three values. The trickier part is to figure out how to figure out if one comes before or after another. When we're trying to figure out if one string comes before or after another string alphabetically, all we do is use the less than and greater than operators. So before we try to put that into the sort method, let's go ahead and just mess around with it up above. Console.log to print it. Is the string A before, using the less than operator, the string B? In this case, yes, A comes before B. If I were to run the script node notes.js, that's exactly what we would see. I get true showing up right here. Now we could also check, for example, if the string March should come before the string January. In this case, I would expect the result to be no. March should come after January since J comes first. If I rerun the file, that's exactly what we get. We get the Boolean false printing. The last thing to consider is that the capitalization is important. So does the lowercase a come before the capital A? And the answer is no. Our capital letters always come first. So in the end of the day, the result of this is going to be false. we're going to address that in our sort function by converting everything to lowercase before we create any comparisons. That's going to make sure that if we did have a uppercase h and a lowercase a, for example, the a would come first, even though it's a lowercase letter and it should come second. I'm going to remove this console.log, and we're actually going to put some of this into practice down below. First up, let's see if a should come before b. If it does, or if it should, we return -1. If. Our condition, our code. The code, super simple. Return -1. It's the comparison where the real work is done. So we're interested in looking at the title property for each, a.title. We could just as easily sort by the body, but I think the title makes a bit more sense. Now, as I just mentioned, we want to take case into account. So I'm going to convert it to lowercase. So we have this lowercase string, and we're going to compare it to the lowercase string, the title from B. Is A less than, right here, the same thing, b.title.to lowercase. If the result of this is true, we know that A should come before B. We return -1. All is well in the world. Now let's add an else if on. Else if. In here, we're going to determine if B should come before A. In that case, as I mentioned earlier, we want to return 1. Right here, what's that operator going to look like? Well, we are going to literally just swap out A for B and B for A. So b.title.to lowercase, is that less than a.title.to lowercase? If it is and B should come first, return 1. Now, the last case we talked about was returning 0. If A doesn't come before B and B doesn't come before A, that means they're identical. In that case, we could just set up a simple else clause and return 0, saying that their order is the same, so there's no need to adjust anything. Now, the sort method doesn't return much of anything. It actually sorts whatever array it's called on. So it's going to modify the notes array directly. That means if we were creating a sorts note function like we are here, there's no need to have a return value or do anything with the return value when you call it. For our purposes, that means down below, we just need to call the function and then print the notes array. I'm going to remove some of the sample code from previous lectures, and I'm going to comment out all of the calls to the other functions just to simplify the output. And down below, all we're going to do is call our sort method, sort notes. We're going to pass in the list of notes we're trying to sort. And then down below, we're going to print out the notes array and see how it changed, console.log notes. Notice I'm not doing anything with the sort notes return value. It's going to be undefined since we haven't explicitly returned anything from the function above. Down below, let's go ahead and save our file and rerun things. I'm going to clear the terminal output for clarity's sake, rerun the notes script, and what I get is H first, M second, and O third. It is indeed showing up correctly in alphabetical order. Up above, we note that this was not the order they were originally defined in. My next trip got swapped with habits. Now we can confirm that the case insensitivity was set up correctly by using a lowercase m, making sure that we still get the same order. If we didn't set up case insensitivity, all of our uppercase letters would come first, meaning that my next trip would actually show up last. But since we did take the case into account by converting everything to lowercase, I would expect the exact same order. Habits first, my next trip second, and office modification third. And there we have it. We now have a way to sort our notes into something that makes a bit more sense. Now, we might have multiple sorting functions for our application. Imagine we have a complex application. Maybe we want to sort by the title. Maybe we want to sort by the last time the note was modified or when it was created. There are all sorts of various criteria that could make sense for your application. For this one, though, it makes sense to sort by the title. Now that we have a bit of experience with sort, you're going to use the sort method to sort our to-do array. Now with the to-dos, we're not going to sort by the text. We're actually going to completely ignore the text when it comes to sorting. Instead, we're going to sort by the completed properties. We're going to put all of our uncompleted to-dos up top and all of the ones that have been completed at the bottom of the list. This is probably what we would do if we were to create a real to-do application. It doesn't make any sense to have completed things up at the top. As always, I'll give you the usage for what we're going to create so we can make sure we're at least on the same page with that. Right here, I'm going to comment out the only other function call we have, and we're going to add a new one into the mix. That is going to be something along the lines of sort, not short, sort to-dos. We'll pass in our list of to-dos and then we'll print them. So console.log to-dos. It's going to be up to you to actually define and fill out the sort to-dos function. Now, I'm not going to give you a lot of hints with this one, even though this one is going to be a little trickier. The general structure is going to be exactly the same as what we saw over here. The only real difference is how do we figure out if one comes before another. That's pretty much all that needs to change. So I want you to think about two to-dos. What makes one come before another? One comes before another if one is completed and the other isn't completed. The one that isn't completed comes first. Based off of just that information, I'd like you to give this one an honest try. And remember, it's okay if you get stuck. We're in the learning phase, not the perfection phase. If this was a job interview, you'd want to make sure that you nailed the question and it worked correctly the first time before you sent it off. For us, as we're learning and exploring, it's okay to make mistakes, try things out different ways, and fall short. That is just fine. All I ask is that you do try to use what you've learned to solve the problem and look back on previous resources if you get stuck. Take some time to try to sort the to-dos and then actually run the code to make sure it works. We should see the ones with a completed value of false, like this one and this one, up top, and the ones with a completed value of true should be down below. Pause the video, knock this out. When you're done, come back and click play. All right, I know that one was a bit trickier, but the goal of this course is to make sure that when it's over, you can actually write JavaScript code. And the only way to make sure that happens is to get you to write JavaScript code during the course. Down below, we're going to kick things off by creating that sort to-dos function. Const sort to-dos. And it'll actually stay scrolled up so we can see the data we're working with. It's going to equal a function that takes in a set of to-dos. And what we're going to do is just call to-dos dot, and right here, we're going to be using the sort function. So sort is going to allow us to specify the order we want to sort things. I'm going to call it with a function since we're not working with a simpler data type like an array of strings. With an array of objects, sort doesn't know what to do unless you tell it what to do. We're going to define our two arguments, a and b. This function is going to get called with both of those. It's our job to tell the function which one comes first by returning -1 if a comes first, 1 if b comes first, and 0 if they're the same. In here, that means we need to set up a series of if statements. Well, actually just one if statement, but it needs an else if and an else clause, just like we had before. So if, what are we going to look for here? We're going to return -1, which means we only want this condition to be true if A should come before B. That means A isn't completed and B is completed. So right here, A dot completed equals false, and using our logical AND operator, B dot completed equals to true. Now, as I mentioned before, when we're working with Boolean values, we typically don't need the equality operator since we already have a Boolean. So this right here is identical to this right here. We already have b.completed being true if it is true. Now, for this, we can't just remove the equality operator and false, because now we actually have the opposite of what we want. Here we're checking if A was completed. We want to check if A wasn't completed, so logical not is going to fix that. It's okay if your conditional was a little bit different than mine. Down below we return -1, and now we can move on to our else if. Else if. In this one, we are going to end up checking if B should come before A. So in the end of the day, we're going to be returning 1 for that. Inside of here, what's the goal? The goal is to check if b.completed is false. So I'm going to flip the value. because remember, we want this to run, which means it needs to actually be true for the condition to pass. Then we use the logical AND operator. We also want to make sure that A dot completed is true. It actually is completed. If both of those are true, then that means B comes before A. Last up, else. If A doesn't come before B and B doesn't come before A, then their order doesn't need to be changed and we can just return 0 for that. And there we have it. This is all we needed to do for the sort to-dos function. We're going to be using a lot of Boolean logic throughout the course in ways like this. So if it's not quite clear or intuitive just yet, I promise that as we practice and write more code using Boolean logic like this, it'll be a little more intuitive. Let's go ahead and run the script though and make sure that what we have so far is actually getting the job done. I am going to clear the terminal output and use node to do.js to test my work. Right here, I have order cat food and do work, both with completed values of false. At the bottom, I have 3 to-dos with the completed value of true: clean kitchen, buy food, and exercise. And that is correct, and it's also not the order we started off in. Previously, I did have do work, which hasn't been completed near the bottom of the list. That did successfully get pushed up to the correct position. So there we have it. We now know how to sort arrays, and that wraps up a lot of the basic things we're going to be doing with arrays. Sure, there are a few others we'll explore throughout the course, but we now have a great understanding of the fundamentals of working with arrays of objects, which is so essential when we're modeling real applications because, as I mentioned before, we can add multiple properties on, giving us a more real-world model of the thing we're trying to model, whether it's a to-do, a product on our e-commerce store, or an email. Now that we have this in place, we're going to move on to the next and final video for the section where you're going to be taking our expense manager, which was originally a very simple application, and you're going to be adding a bit more complexity to it using what we've learned in this section. I'm super excited to get to that. Let's jump right in. In this video, it's going to be up to you to build a new version of our expense tracker. Previously in the course, we did build a little expense tracker app when we learned about objects and functions, but if you remember, we kept track of expenses via a single number. If we added a new expense, we just added it on to that single number. And this is okay, but it's not really great because we don't have a list of our expenses. So I can't figure out how much I'm spending on food, for example, and I can't see the individual cost of each expense. Now that we know about arrays of objects, we are going to model each expense using an object. That's going to allow us to have multiple pieces of data. We're going to have an expense description as well as the exact amount of the expense. That is going to allow us to search our expenses, delete expenses, and we'll still be able to analyze our data and get a total. Let's go ahead and kick things off by creating a brand new file in the arrays directory. I'm going to call this one expense-tracker.js, and in here we are going to break up this video into 2 separate challenges. So let's talk about what the first challenge is going to contain. Together, real quick, let's go ahead and create a const variable, and I'm going to call this account. This is going to be our starting place. It's going to be a simple object with 2 properties: name, the account holder's name, I'll just use my name, and expenses. Although expenses is actually going to be an array. So this is where we're going to store all of the various expenses. Down below, let's go ahead and document a few things related to what should be in expenses and what methods I'd like you to add to work with the account object. First up, the expense itself. So each expense is going to model a real world expense. And for now, we're going to model it using 2 properties. The first one is going to be the description, which is going to be a string. So if I am getting coffee, the description might be coffee at Capital One Cafe, for example. The other property is going to be the amount. The amount is just going to be a number of how much you spent. So if I spent $2 on coffee, I would pass in 2 as the amount property value. Now this just defines what should go in expenses. You're going to be creating methods to actually put things in expenses and analyze the data that's already in there. For this first challenge, there are going to be 2 methods, so functions as object properties on account, that I want you to create. The first one is going to be add expense, and the second one right here is going to be get account summary. So let's talk about add expense first. The add expense method is going to take two arguments. We are going to take in first the description for the expense, and the second one is going to be the amount. So we're taking in these two arguments, and what we need to do in add expense is add a new object onto the expenses array with the correct data. We have both of the pieces of data in as arguments. All we have to do is create that object and add it onto the list. Now that's going to allow us to populate the expenses array. The other method that you're going to be creating isn't going to take any arguments at all. Get account summary is going to total up all expenses, and you're going to print a little message like the following. Andrew Mead has, then right here the $sign. Let's just say it's 1,250 in expenses, for example, where this is the account name, and this is a total that you're going to have to calculate. If you want to calculate the total, all you need to do is use for each to go through every single item in the expenses array. You can get the amount object and add it on to a variable. As you keep changing that variable, you'll come up with the total in expenses, and then you can add it into the template string. As always, feel free to use anything we've learned so far to get all of this done. Down below, let's go ahead and add a few calls just to make sure you're on the right track. Account dot add expense. I'm going to add it right here. Let's say it's rent. Let's say it's 950 bucks. I'll add one more. Account dot add expense. Let's say this one is coffee. I'll add this one at $2. Then the last thing I'm going to do is use our other method. So I'll use console.log to actually print something, and account.get account summary, and I am going to call it with no arguments, expecting my string to print, saying that Andrew Mead has $952 in expenses. All right, pause the video, knock this out, test your work, and when you're done, click play. All right, how'd that one go? Hopefully you were able to get that done without too much trouble. First up, let's go ahead and create our add expense method. The method is going to live right on the account object alongside of our data. So right here, add expense. I'm going to set it up as a method by setting its value equal to a function. Now, does this function or method need to take any arguments? And the answer is yes. We set this up to take two different arguments, the description and the amount. We get both of these, and it's going to be our job in here to add a new item on to the expenses array. How do we get access to that array? Well, if you remember from the previous sections, we used this to access that object. So this would give us the object, dot expenses would give us that array. How do we add a new item on to an array? Well, we could have used onShift to add things to the beginning, or we might have used push to add things on to the end. I'm going to go ahead and use push, though the other way would be perfectly fine. Now, what are we going to do with push? Well, with push, we pass in the item to add on to the array. We have an array of what? We have an array of objects, so we need to create an object right here. You might have defined this object as a variable up above and then passed it in. That would be fine as well. Now, what needs to go on this object? Well, I mentioned that each expense needs a description property and an amount property. So I'm going to create a description property and set it equal to description. And down below, I'm going to create an amount property and set it equal to the amount argument value. Now, that's all we need to do for add expense. At this point, it should be working correctly, manipulating our expenses array. The other method I wanted you to add was get account summary. Right here, we can add that after add expense, comma, enter, get account summary. We set this up as a function. This function actually doesn't take any arguments. Its job is to just calculate up all of the expenses and then print a little summary. So to get this done, I suggested that you use for each, but I didn't really tell you anything more about that. Now, you might have gotten stuck and referred to the web to figure out how this works, and that's okay. Coming up with a solution based off of your research is a great way to solve a problem. What I wanted you to do was create a variable right here. And you could have called this something like total expenses or anything else, and we're going to start this off at 0. Now, what we're going to do is return our template string. return a little template string. In here, we start off with the account holder's name. So $ curly braces to interpolate a value. That would be this dot name, then has followed by the $. Now we want to actually inject the bounce. So right here, $ curly braces. That would be the total expenses variable from above. And then after that, we just have the static text in expenses, period. Now at this point in time, we could run the program. The only thing is that total expenses isn't going to contain the correct value. I'm going to do just that. Over in the terminal, node expense tracker.js. When I run the script, I get Andrew Mead has $0 in expenses. So some stuff is working, some stuff is not. How do we add up all of the expenses? Well, we want to do something for each expense. When we want to do something for everything in an array, we use for each. So right here, what you should have done is used this .expenses .for each. This is going to allow us to pass in a callback function. And we know that with this callback function, we get access to the individual item. Since this is an array of expenses, I can call this individual one an expense. Down below, what are we trying to do with the expense? We're trying to use its amount property to increment the value above. So total expenses is going to equal the old value for total expenses plus the amount property on expense. So expense dot amount. Now we're actually going to be adding up all of the expenses, and in the end of the day, total expenses is going to have the correct value as opposed to 0. If we save the file and rerun things from the terminal, I get Andrew Mead has $952 in expenses, which is indeed correct. So there we have it. We have our little expense tracker. It went from using a single number to track our expenses to an array of objects, allowing us to more accurately model data that we're probably going to want to store. And now it's time for our part 2 challenge. For part 2, we are going to take income into account. So right here, let me outline what I'd like you to do. First up is going to be add an income array to the account. So we can start this off as an empty array like we do for expenses. Then as step 2, you're going to set up an add income method. And this method is also going to take a description. So is the income from your job, a side project, whatever, and an amount. How much did you make? Now, this alone is going to be very similar to what we already have, but instead of expenses, it's going to be income. What I'd also like you to do as the third and final step is to tweak get account summary. So much like we had in the previous example, what I want you to do is figure out how much I have in expenses, how much I have in income, and then my account balance. So the income minus the expenses. And you're going to print a more complex summary, and that's going to look a little bit like this. Andrew Mead has a balance of, followed by my balance. Let's go ahead and say it's $10. And then I would talk about my money in income and my money in expenses. So right here, I could say 100 in income, and then I would say 90 in expenses. So in this situation, I have 100 in income, 90 in expenses. That brings me to an account balance of 10. It's going to be your job to not only calculate the total expenses like we already have, but also the total income and the balance. Then when you're done, all you really need to do to switch things up is to add a little bit of income into the mix. So right here, I could say account dot add income. And let's say I just add it from my job. And let's say I make 1,000. So what does that leave me with? That should leave me with $48 as my final account balance. Take some time to knock this one out and then test your work. Once again, if you get stuck, refer to anything out there, pause the video, come back, and when you're done, click play. All right, how'd that one go? Hopefully you were able to get that done. Let's dive right in by first creating that income array. So this is going to be a piece of data alongside of name and expenses. I'll call it income, and I'm going to start it off with nothing. Though if we were loading data in from some sort of saved location, like we'll do later, we might have some data already populated when the application starts, but not now. Down below, after add expense, we're going to add the other method. That's step 2, add income. Add income is going to look super similar. It's just going to be working with the income array instead of the expenses array. The arguments list is identical. We have our description and we have our amount. Down below, we add a trailing comma separating our properties. Now, what do we do inside of here? We access this .income.push to add that on. We push on a new object. Income, just like expenses, is an array of objects. We set description equal to the value passed in from the description argument. Then we add a comma, hit enter, and we add on amount, setting the amount property equal to whatever was passed in as the amount argument. The next thing we needed to do was step 3, which is to tweak get account summary. We want to take the income into account as well. I want to add up not just the total expenses, but also the total income, and then I want to include all of that information in my template string. So right here, I'm going to create a few other variables. First up, let total income equal 0, and then let account balance equal 0. So all of these start off at 0. We are going to change total income using a for each loop, just like we did for expenses. So right here, before or after the other one, it doesn't really matter. This dot income dot for each, passing in our callback function. We do need to access the item. So right here, I will define that argument income, and then down below, all we're going to do is manipulate total income. Total income equals the old value for total income plus the new value. The new value comes from income dot amount. Now we're going to be successfully summing up all of the pieces of income. And before we actually go through the process of changing this template string, we want to update the account balance. So right here, the account balance is now equal to, it's going to equal the total income minus the total expenses. This is going to give us our account balance. Now we have all of the data necessary to fill out the string down below. So we are still going to start off with the name. This name, and then right here, has a balance of, we add the $, and then $ curly braces to inject the account balance, which I stored in the account balance variable. After that, we add a period and we move on to the income. So I'm going to add a $, and then inject the income, that is total income, followed by the words in income, period, then a $ for expenses. We inject it with $ curly braces, total expenses, which we already had defined, and then right here, the words in expenses, period. So this is going to give us everything we were hoping for. We're adding up both, we're getting our account balance, and we're dumping it all in the account summary return value. Let's go ahead and actually test our work by removing the comments down below, saving the file, and over inside of the terminal, I am going to rerun that script. I rerun the script, and what do I get? I get an error. Right here, total income is not defined. Now, this is a real error. This isn't me trying to create an error just to prove a point. I actually made a mistake. Now, at this point, in real time, I have two choices. I can choose to scratch this. I can stop recording the video, and I can go back and do it right, or I can continue on. And I'm going to make the choice to continue on because I made a real mistake. So let's go ahead and solve it. Right here, total income is not defined. Right away, I see that I didn't name total income with a lowercase I, which means I must have mistyped it somewhere. And if I do dig into the code, I can see total income, and then right here looks good. Here it is. So this is where the error lives. All I do is replace the lowercase I with the uppercase I, cross my fingers, and rerun the script again. Creating errors and fixing them is part of normal life. Clear. Up arrow key twice, we rerun expense tracker, and this is what we get. Andrew Mead has a balance of $48, $1,000 in income, $952 in expenses. And with this in place, we are all done with this video. In this one, you are required to use a lot of the stuff we learned so far in the course. And this is great because the more code you write in the course, the better shot you're going to have of being able to use JavaScript in a productive way once the course is over and I'm gone. The guidance is great, but it's also important to get comfortable writing things on your own, coming up with new ideas for how to solve problems. That's where we're going to stop for this video, and that is also the end of this section. In this section, we learned a bunch about arrays and how they're going to allow us to model real-world pieces of information, like a list of expenses or an array of notes. Now, this was also the hardest section in the course. So if you're feeling a little discouraged about the speed of this section, I promise that not only are we going to slow down a little bit in the next section, we're also going to finally tie our scripts to a real application. So we're going to start integrating some of this stuff into JavaScript in the browser, allowing us to do things like get our description and amount from the user via a form and display the account summary inside of the web page. I'm really excited to get to all of that and more. Let's go ahead and jump right in to the next section.